Hello students, welcome to RD Chemistry. In this video, I will explain oxidation of aldehydes and ketone. We have got primary alcohol which can be written as the RCH2OH. On oxidation, they give rise to aldehyde RCHO. On further oxidation, they give rise to the carboxylic acid RCOOH. Whereas the secondary alcohol of this structure can give the corresponding ketone, and ketone can be oxidized to give the carboxylic acid in the presence of stronger oxidizing agent, because the carbon-carbon bond can break and the carboxylic acid form as a lesser number of carbon atom. Now, in this video, we will see the oxidation of the aldehyde to the carboxylic acid, ketone to the carboxylic acid. Now, if you want to convert aldehydes ketones, we can make use of the potassium permanganate, strongest one. We can make use of the Tollens reagent. We can make use of the Fehling's solution. We can also make use of the potassium dichromate in the acidic medium. Okay, but the conversion depends on the type of the molecule used, either aldehyde ketone, and the reaction condition. So let's proceed now. The mild oxidizing agents like Tollens reagent and Fehling's solution oxidizes aldehydes to the carboxylic acids, but they do not react to the ketone. Ketones are not oxidized. Therefore, this is a test to distinguish between aldehydes and ketones. Remember this. Let us see what is this Tollens reagent test. Tollens reagent is ammoniacal silver nitrate solution, and in this case the reactive species is this one, the silver complex with the OH minus. That means it is a alkaline medium. Now we should be careful when there is alkaline medium. Now what will happen? Tollens reagent react to the aldehydes in the ammoniacal silver nitrate solution to give silver mirror precipitate. Silver is formed due to the formation of the silver metal, and aldehydes are oxidized to give carboxylic acid. Since we are using the basic medium, it will be the anion part. Okay, so silver is a +1 state in the Tollens reagent, becomes silver 0 state in the product state, so it is a metal, a precipitate. Okay, ketones do not react because these are mild oxidizing agents, so you can distinguish. So here we get mirror, silver mirror, precipitate. Okay, now let us see what is this Fehling's solution test. Fehling's solution comprises of two solutions, Fehling's solution A and B. So solution A is aqueous copper sulfate solution. So we have got copper +2, and in the basic medium, remember this is a basic medium. Solution B is the alkaline solution containing sodium potassium tartarate, and tartarate nothing but it is the Rochelle's salt. Okay, only aldehydes react to the Fehling's solution to give red precipitate of cuprous oxide. So cuprous oxide is formed here. Simultaneously, aldehyde becomes the carboxylic acid but forms the anion of the carboxylic acid, because we are using the base sodium hydroxide or hydroxide there. Okay, aldehyde only reacts, ketones do not react. But then exception, if there is an aromatic aldehyde like a benzaldehyde, they should have answered Fehling's test to give the red precipitate of cuprous oxide. But what will happen here? They will not give the red precipitate, and instead it undergoes Cannizaro's reaction. And Cannizaro's reaction discussed in the last video. Now why it is undergoing Cannizaro's reaction? Because here the basic medium is present. In the presence of hydroxide medium, if the aldehyde does not contain alpha hydrogen, it can undergo Cannizaro's reaction. Okay, right? Next one is the haloform reaction. Haloform reaction mainly for methyl keto compound. What is methyl keto? Methyl keto means compound should contain CH3CO double bond group together. It can be any other group other way around. Okay, so here it will be R can be hydrogen, R can be CH3, R can be benzene, R can be methyl, but there should be CH3CO group together. When we say haloform reaction, it can be bromoform, it can be iodoform, it can be chloroform. What is the reagent we make use of? We make use of halogen along with the sodium hydroxide basic medium. Now, this combination can also be written as a NaOX, sodium hypohalide. So, okay, NaOX means it can be NaOCl, NaOBr or NaOI. Okay. Sodium hypochlorite, sodium hypobromide, sodium hypohydride. Okay. So, if there is a COCH3 group, then it breaks. RCO becomes the carboxylic acid salt and CH3 becomes the chloroform, haloform, bromoform. If it is the iodoform, it will be the yellow precipitate here. Okay. So compound must contain CH3, CO group together. Right? Remember student, even alcohols can also answer. Alcohols of the type CH3, CH, OH, some other group R, which can be hydrogen, which can be benzene, which can be alkyl group also. Now why alcohols can answer? Because the sodium hypohalite used is the oxidizing agent. So it can oxidize this kind of alcohols to the type CH3, C, double bond O and R. Then this is a methyl keto compound we are going to get. It can further react with the sodium hypohalite to give finally carbon-carbon bond breaks. We get CHI3 iodoform in case of iodoform, in case of the iodoform reaction, plus sodium salt of the carboxylic acid. Okay, fine. Let's see the questions now. When ethyl alcohol passed over red hot copper at 300 degrees centigrade, formula of the product formed is ethyl alcohol is a CH3 CH2OH. It is heated in the presence of copper heated to 300 degrees centigrade. The use of copper is a dehydrogenating agent. Dehydrogenation is nothing but the oxidation. And this is a primary alcohol. Primary alcohol becomes a corresponding aldehyde, and the corresponding aldehyde is the 2 carbon atom. We are going to get this acetaldehyde or ethanol. Okay. So the answer is option number 1. Question number 2. Failing solution will oxidize. It reacts only with the aldehyde, not with the ketone. This is alcohol. This is ketone. So we have got here benzaldehyde and we have got aldehyde. They are supposed to react with the aldehyde. But what will happen if there is an aromatic aldehyde like a benzaldehyde? It undergoes Cannizaro's reaction because there is hydroxide medium, basic medium. Therefore, aldehyde can be easily oxidized to give the sodium salt of the carboxylic acid. Right? Can be oxidized. So answer is option number 4. Haloform reaction is not given by. There must be CH3CO group. Can answer. CH3CO group can answer. But in the option number 3, benzene is there, attached to CO, then attached to CH2 and CH3. There is no CO, CH3 together, therefore it cannot answer. What are the option number 4? We have got CH3, CH, OH and CH3. In the haloform reaction using sodium hypohalite, which is the oxidizing agent, it can oxidize this secondary alcohol to corresponding ketone, that is the CH3, C, double bond O CH3. This contains CH3CO group together, so it can answer the haloform reaction. Therefore, which cannot answer is option number 3. 3 is the answer for this question. Question number 4. Organic compound alcohol has been given, that is a CH3, CH, OH and CH3. This is a secondary alcohol, right? Secondary alcohol is treated with the potassium dichromate, that is the oxidizing agent. So secondary alcohol becomes corresponding the ketone. So we are going to get acetone here now. This is supposed to be Y. Okay, this is Y compound, which reacts with the iodine and sodium hydroxide. This is the iodoform reagent. So you get triiodomethane. That means we are going to get iodoform and corresponding salt of the carboxylic acid. Okay, so therefore Y should be acetone here. Second one is the option. Correct. Question number 5. the compound given C2H5, that is a CH3, CH2, CHO, propanol, and they are given CH3, COCH3, ketone. One is aldehyde, other ketone. Can be distinguished by one another by testing with phenyl DNPH, and sodium bisulfide will react with both of these. We can't distinguish. So failing solution, know that failing solution reacts only with the aldehydes but not with the ketones. So therefore failing solution can answer the aldehydes but not ketone. Answer is option number 3. Question number 6. Isomeric ketones pentan 3 on pentan 2 on can be distinguished. We'll write the structure. Pentan 3 on CH3 CH2 ketone is there on the third oxygen, third carbon atom, correct? Then we have got CH2 and we have got CH3. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Correct? 3 pentanone. 2 pentanone CH3 on second carbon atom ketone. Then CH2, then CH2, then CH3. Correct? Carbon number 1, 2, 3, 4, 5. There is a iodine and sodium hydroxide, which is a haloform reaction. Haloform reaction is answered by those compounds which contain CH3CO group. Second compound can answer. First compound cannot answer. So we can distinguish because one reacts, other does not react. Whereas sodium bisulfide and addition of HCN takes place on both these carbonyl compound. So the answer is option number 1 here. Okay. Question number 7. In the given transformation, which of the following is the most appropriate reagent? See carefully. CO has become CH2. Carbonyls are reduced. Double bonds remain as such. OH remain as such. Conversion of C double bond to CH2 either by Clemenson's reduction, that is zinc mercury amalgam, concentrated HCl, or we can make use of Wolff-Kishner reduction involving hydrazine and KOH medium. Correct? Now which is the best answer? If I make use of the acidic medium here HCl, so what will happen if there is alcohol? This is alcohol group. Alcohol ROH can react the HCl to give alkyl chloride. So there is a possibility. So you cannot make use of the acidic medium because alcohols are acid sensitive. They can undergo dehydration. So we must make use of the basic medium. So therefore answer is option number 4. Okay. That is a Wolff-Kishner reaction. Question number 8. They are given ethyl alcohol PCC. PCC is a mild oxidizing agent. So primary alcohol is oxidized with corresponding aldehyde CH3CHO. Correct? And this is an aldehyde which is treated with a basic medium. Remember, aldehyde is a basic medium which reaction. This aldehyde contains alpha hydrogen atom. In the presence of the base, it can undergo aldol condensation or aldol reaction. Aldol should be formed. Aldol, aldehyde plus alcohol. Therefore, addition product formed is aldol here. Therefore, answer is option number 4. Right? Please do like, share and subscribe RD Chemistry. Thank you for watching. Have a nice day.